Sid, come here. Come here. I want you to say into the microphone TK to YouTube.
TK to YouTube.
Say it louder.
TK to YouTube.
Nice job. That's my intro.
Really?
Mm-hmm.
Is that recorded?
Yeah. Good job. All right. End of the line, gang. Got the endocrine system on deck, all right? And I know you guys have been talking about this in lecture, so it should be a little bit of a review for you guys when we're talking about some of these things. But the big thing that we're going to try and hone in on with this lab is going through the negative feedback pathway cycles. And that's probably what we're going to do. So obviously we have 4 learning objectives this week. Nothing too crazy compared to the last week. We had 14, so a lot more relaxed this time around. 4 this time. So first one, identify the indicated endocrine organs on figure 13.1, which is super easy. We'll show that in a second. Name the hormones produced by each endocrine gland, which is right here, number 1. Another super easy one, okay? Draw the hormonal feedback pathways that regulate the thyroid hormone. All right, so these are the big 3 hormones. So thyroid, cortisol, and testosterone. Those are the 3 big ones we want you to know, okay? Now, we have a lot of other ones here, obviously, but the 3 that you should really hone in on so you know what happens if either the amount of release from those hormones either goes down or goes up. You should know what happens from these 3 guys, okay? And then indicate how hormone imbalances impact hormone levels, gland size, okay? So, introduction here. As you know, endocrine system is a diverse group of ductless glands, all right, that play a major role to regulating the body's homeostasis. Endocrine system works via secretion of hormones, all right, which are these chemical messengers that are secreted into the bloodstream, okay? Communication through the endocrine system is not immediate like that of the nervous system. Rather, the effects of hormones can take either time, minutes to hours, and are much longer lasting, okay? Take hours or days for them to wear off. So, let's talk about this one. This first learning objective is down here. This is learning objective number 2, okay? Let's talk about it real quick. So we have a bunch of different groups of hormones. We have 9 different groups, okay? We're going to associate them with each of the glands respectively. The first, like I said, some of them are much easier to recognize just because, what gland secretes them is in the name. You've probably heard of some of these before. Some of them you've probably never heard of before, okay? We'll go through these. So the first 2 grouped together are estrogen and progesterone, okay? These are the big-time female sex hormones, okay? And I'm sure that you've probably heard of these at some point in time in the past. And what produces these guys is actually the ovaries, the primary sex glands for the females. Okay, very straightforward. Next one is another very straightforward one. So TH, this is the thyroid hormone. So what produces this? Well, it's going to be the thyroid gland. Okay, very easy one right there. Nice job. Then we have oxytocin and ADH. Okay. So this is the first of the ones maybe you've heard of, maybe not before. But this is actually produced by the posterior pituitary, okay? That's letter C there. ADH is a unique one. It stands for antidiuretic hormone. And if anybody has ever partaken in drinking adult beverages and wonder why you have to go to the bathroom so much, this hormone is completely blocked from being released. So antidiuretic means you don't have to go to the bathroom. But if we block your ability to release this, that means we're going to let the floodgates open. So alcohol prevents this guy from being released, which is why you have to go to the bathroom so often if you drink adult beverages, okay? Then we have a whole group of 5 here. So LH, FSH, ACTH, TSH, GH. So a whole bunch of group. I'm not going to describe what each of these are, okay? But majority of these are stimulating hormones, okay? And if they're a stimulating hormone, which means that they're released from the anterior pituitary, okay? If they have some sort of stimulatory effect, all right? They're stimulating something else to be released down the chain. Testosterone is a very common one. I'm sure many of us have heard of it. It's the primary male sex hormone, testosterone. We use it a lot for building muscle, but also for exhibiting our male characteristics, such as deeper voice, bigger testes, etc. And the gland that secretes this guy is the testes, all right? And we have parathyroid hormone. What releases this? Another very easy one. It's going to be the parathyroid glands. Okay, it's letter E over here. Another easy one, straightforward. Insulin and glucagon. If anybody knows anyone, either a friend or a family member, has some sort of a diabetic pathology, whether it be pre-diabetes, type 2, type 1. These are the hormones that are primarily associated with, primarily insulin, but glucagon is also associated with the pancreas. Okay, so that's what the gland is. The pancreas is affected in diabetic pathologies. And then we have these 4 groups of hormones. So GnRH, CRH, TRH, and GHRH, okay? Notice the big letter in these guys is R, okay? See 4 R's. R means releasing, okay? There's only one gland here that allows these guys to be secreted, okay? And that is the hypothalamus. So if you ever see an R like this, a releasing hormone, okay, that's always coming from the hypothalamus, all right? So letter A is the hypothalamus, all the releasing hormones. And last but not least, that leaves the last one here, cortisol, that is released via the adrenal glands, via the adrenal cortex, and more specific, but the adrenal glands is fine too, okay? All right, learning objective number 2, easy peasy. All right, just a little matching activity here, knowing which hormones are secreted where. Easy, awesome. Another one right here, okay? Learning objective number 1. So if we were to show you a picture of this on your guys' lecture final, and we asked, we drew an arrow to a specific gland of some sort, we asked you to identify what it is, you should be able to do so. So just making sure that we can look at this picture, we know what the arrows are pointing to for the specific glands of the endocrine system, and you'll be golden. All right, no BS here, just memorizing the picture, know what's going on. Okay, very easy. Okay, so hypothalamus. I'm sure you guys have already chatted about this in lecture, but the hypothalamus is often considered to be the master command center with all of this, okay, for the endocrine function. The hypothalamus contains neurons that produce releasing hormones, RHs, as we talked about above, all right? They control a wide variety of functions. When the hypothalamus is stimulated by a particular stimulus, so if you have a low, essentially if you have a low hormone, low threshold for hormones, so let's say your testosterone levels are down, your hypothalamus is going to get word of that, okay? Something's going to go and tell that guy that your testosterone is low, so what's going to happen is that it's going to start releasing these releasing hormones, okay? No pun intended. It's going to allow these releasing hormones to be released so we can start to stimulate to produce more testosterone. The neurons release a specific hormone into a special set of blood vessels called portal blood vessels, and it carries those hormones directly from the hypothalamus to the anterior pituitary or the posterior pituitary, okay? Regardless. The anterior pituitary gland will respond by releasing its own hormones, into the bloodstream. The hypothalamic hormones are often called releasing hormones, the RHs, as I said above, and the anterior lobe hormones have a stimulating effect to them. So you can see some of them have stimulating in the name here. All right. So you can see these blood vessels here. They start up in the hypothalamus and they run all the way down into the anterior pituitary, but they also run down to the posterior too. But we're focusing primarily on the anterior lobed pituitary hormones here. All right. Just another little example, just breaking it down a little bit further. So what's going to happen? So hypothalamus gets some word that we need some more of a particular hormone in the body. We can see all the RHs here, all the releasing hormones. They follow their respective pathways here. All right. So for example here, so the green pathway. So the hypothalamus is going to release testosterone levels low. It's going to release GnRH, all right, gonadotropic releasing hormone. That goes down to this guy right here. This is the anterior pituitary, or we call this guy the ANT-PIT, all right, in class. Tells that guy, hey, we need another particular set of hormones to go and tell the testes to produce more testosterone. So the anterior pituitary is going to release LH, okay? FSH is primarily for the ovary, but LH is for the testes, okay? So it releases LH, all right? LH is luteinizing hormone that goes down and tells the testes that we need more testosterone to be produced, all right? So the LH is basically the messenger, letting the testes know to produce more testosterone, all right? So it follows these pathways here, okay? They all go to their respective glands as is indicated by the different colored arrows. So pretty straightforward here, okay? All right, scroll down a little bit more. So I know they talked about this in lecture. They talked about the negative feedback pathways and everything. The common analogy that almost anybody gives for this is going to be with a thermostat in the room. So for example, you have your thermostat set at 70 degrees Fahrenheit, right? And now it's in the cold winter months right now, so your temperature is probably dropping low, right? So let's say it drops down to 68 or 69 degrees, right? So your thermostat gets word of that. So what's going to happen is it's going to kick on your furnace. It's going to tell your furnace to start pumping out heat, right? We got to get that temperature back up to 70 degrees where it's supposed to belong. Starts pumping out the heat. As the temperature starts to rise, and when it hits that threshold or it goes over that threshold, all right, what's going to happen is your thermostat is going to tell your furnace to shut off, okay? Because we met that threshold of 70 degrees, so we don't need any more heat, all right? Exact same concept comes to the hormonal pathways with the endocrine system, okay? So in our case here, we're considering the hypothalamus to be that thermostat for us, okay? So when it gets word that something's not right, so we are at a lower percentage of a certain hormone, it gets told that, so then it tells your furnace, aka your anterior pituitary, and if you work down the chain, it'll tell another gland, your thyroid, it'll tell your testes, your ovaries, whatever, to produce a certain hormone, okay? Produces that guy. When it gets up to that certain threshold, the hypothalamus, your thermostat's going to get word back that things are back up to speed where they're supposed to be, and it's going to shut off that entire cascade because we're back up to our homeostasis. So we're back where we need to be, all right? So the furnace, the thermostat pathway, the exact same thing for the negative feedback pathway as the hormonal endocrine system, all right? And it gives you a little example down here, okay? You just follow the lines here and the numbers, 1, 2, 3. And it tells you the the order that the events will happen. Okay, in a normal circumstance, we'll talk about the abnormal circumstances too. Okay. All right, so let's talk about an example here. Okay, we're gonna go through all the normal examples. We'll go through all the abnormal examples. Okay. We'll do the normal ones in this first video, and then we'll go through all the abnormal ones in the next one. Okay, because there's a lot more abnormal than the normal. All right. So in the normal pathway for the regulation of thyroid hormone, what's gonna happen? Okay. When you look down at this picture here, it's always going to be the exact same things in the first two boxes, okay? The third box is what the target gland is going to be for the specific hormone, okay? So where is my text box thing here? Text box, all right? So what's always going to be in the first box is going to be the hypothalamus, all right? Always, always, always. The master command center, remember? That guy always goes first. And then it's going to be the anterior pituitary. All right, always going after. Now, in this case, what it wants us to do is talk about the regulation of the thyroid hormone, okay? What produces that is the thyroid gland. So we'll put that in the last box here, respectively, all right? So now we know what organs we're going to be working with. So then we have to fill in the blanks of what the rest of the cascade is going to be, okay? So remember, hypothalamus releasing hormones, all right? No pun intended, the RHs. So in this cascade, in relation to the thyroid gland, it's going to release TRH because of that. Okay, TRH is going to go down and tell the anterior pituitary to release TSH, thyroid stimulating hormone, TSH. Let's put this guy in the middle here. And the thyroid is going to release TH, thyroid hormone. All right, very, very easy ones here. Okay, they all start with T. RH for the hypothalamus, SH, the stimulating for the anterior pituitary, and then thyroid hormone for the thyroid gland. Okay, now we have these little circles here. What these are supposed to be indicating is is it being stimulated or is it being inhibited, okay? In a normal pathway, this is what it's always going to look like, okay, down the cascade. So if it's a normal pathway, you're always going to have a plus here. You're always going to have a plus here, okay? And then in these two ones over here, what's going to happen is you're always going to have a negative, you're always going to have a negative, and I'll explain why in a second, okay? But it's always plus, plus, minus, minus in a normal pathway, okay? So that's what the cascade's supposed to look like, okay? When it comes to normal pathways, you always start up with the hypothalamus, all right? You always start here, and you work your way down and back around, okay? So what's going to happen? So hypothalamus gets word, okay? TH levels need to come up, all right? So what's going to do, as I said, it's going to release TRH, okay? So these levels are going to go up. So because of that, because this is going up, it's going to stimulate the anterior pituitary via the plus here to produce more TSH, okay? So this is going up. Because that's going up, we have the plus here because it's stimulating the thyroid to produce more TH. So this goes up, okay? So this arrow here, what it's indicating is what's the effect of this going up, okay? So what thyroid hormone is responsible for is increasing metabolic rate, increasing your sympathetic nervous system effects, so increasing your heart rate, your respiration rates, your alertness, etc., okay? So let's say increase metabolism and increase SNS effects. And that would be like your heart rate, like I said, your respiration rates, and your alertness. All right. So that's a normal pathway. What would happen, okay? So now what happens? So TH goes up, perfect. So we hit the threshold, all right? We hit the threshold. We have enough TH in the bloodstream. It's doing what it's supposed to do. So when we don't need any more, what's going to happen is since we have a high enough level of TH, it's going to go up via these dotted lines, and it's going to tell the anterior pituitary and the hypothalamus, hey, I'm good, man. I don't need any more. All right, I'm at my threshold. Come back and talk to me when I need some more, okay? So it's going to shut these guys off via the minus, okay? That's what the minus indicates. It means it's going to inhibit more production of these other hormones. TRH, TSH with all together will bring an increase in TH, all right? So in a normal pathway, you start up at the hypothalamus, you work your way down and back around, okay? So you always stimulate. Once you have enough, then you inhibit via the minuses, all right? Very, very easy. So how do we do it with the other ones, okay? How do we do it with cortisol? How do we do it with testosterone, okay? What's going to happen? So cortisol release, okay? Hypothalamus, anterior pituitary, and adrenal glands. All right, that's the cascade we're working with. Remember, the first two boxes in a normal pathway are always the same, okay? So we have the hypothalamus here. Thalamus. And then we have anterior pituitary. And then in this case, what the last gland is in this cascade, because of cortisol, is going to be the adrenal glands, all right? Or the adrenal cortex, to be more specific. And remember, in a normal pathway, what are these boxes, what are the circles always going to look like? It's always going to be a plus here, always going to be a plus here, always going to be a minus here, okay? So now what hormones, okay? What hormones are coming out of these guys, all right? So hypothalamus for the cortisol pathway, it's going to release CRH, corticotropin releasing hormone, okay? So we'll put that in here, CRH, perfect. So we know that these levels are going up. So because those levels are going up, it's a releasing hormone. It's going to tell the anterior pituitary then to release adrenal corticotropic hormone, ACTH. Okay. Perfect. So that level is going up. So since that's going up, it's going to stimulate via the plus the adrenal glands to secrete. We'll just write this one out because I've been drawing everything. So we'll do cortisol. Okay. So what is the effect of cortisol then? Okay, what does cortisol do? So what this guy does is it helps to increase your blood glucose concentration, conc, right there, conc, C-O-C, C-O-N-C, promotes fat and protein catabolism, all right? Fat and protein catabolism, which is basically the breakdown. Okay, catabolism is the breakdown of those things, okay? And comma. And what else does this guy do? It's also anti-inflammatory effects. All right, and it also helps suppress your immune system as well. And suppression of, I think that's how do you spell suppression? What the heck? Why is it wrong? There we go. Okay, 2 S's, 2 P's. Suppression of immune system. All right. So that's what the overall effect of this thing is going to be, okay? When you have enough of that in your bloodstream. So perfect, I have enough cortisol. It's going to go up and tell anterior pituitary, hypothalamus, I'm good. I don't need any more. So it's going to shut those guys off via the minus, okay? So it's going to tell them to shut off, all right? All right, testosterone. So same thing here, okay? So copy and paste. Hypothalamus always goes up top. Anterior pituitary always comes second here. Something looks a little bit different here, though. What's going on? So what we have going on here, all right, is we actually have an extra gland here at the bottom. But in this cascade, what's going to come first is the testes, all right, because that's what produces the testosterone. And what testosterone can also influence is the prostate gland. Now, there's no effect that we need to know about what happens there. What it's going to be asking us for is the gland size, as we'll talk about later, okay? So what's testosterone going to do? It's going to stimulate the prostate, so it's going to be building a bigger gland size, okay? We'll talk about gland sizes in a second. Prostate, perfect. And then what's our cascade always look like? Remember, it's always a plus plus in a normal situation, and then minus minus right here. And in this case, since we're going down, we're also going to have a plus right here with the prostate, okay? So let's fill in the hormones then, okay? So what does the hypothalamus release? It's another releasing hormone. It is GnRH, so gonadotropin releasing hormone, okay? So since those levels are going up in a normal pathway, always start at the top. It's going to stimulate the anterior pituitary with the plus there. All right, perfect. What that guy is going to release is LH, luteinizing hormone. That level is going to go up and it's going to stimulate the testes via the plus once again. And what does this guy release? This is the testosterone hormone, all right? The male sex hormone. All right, so what is the effects of testosterone? Excuse me. Testosterone is going to do is going to help with growth and maintenance, all right, of other male organs. Is going to be the stimulation of sperm production and increased growth of muscle and bone synthesis, respectively. All right, so that's the effect of it. All right, and then per usual, you start up at the top, you work your way down. When you have enough testosterone, you're going to work your way back up, and you're going to have a minus symbol up in the other boxes, up in the other circles, because once you have enough testosterone, you're going to tell the hypothalamus and the anterior pituitary to shut down because of it, all right? So they're going to shut down. Perfect. All right, so guys, I want to take a break here. Next video is starting to dive into the abnormal examples, all right? So what's going to happen if we throw something off in the negative feedback pathway? So if we were to have a tumor of some sort, if we were to inject ourselves or give ourselves supplements of a certain hormone, what's going to happen in the cascade? So these are the normal examples as I talked about. All right. Remember, you always start at the top, the first rule. All right. We talked about the rules in class. If it's a normal example, you always start at the top with the hypothalamus and you work your way down. And then we'll talk about what the second rule is down here with the abnormal pathways. All right. So we'll come back in a second, finish that guy off, and we'll be done. All right, guys, be back.